Support for this podcast comes from the Central Valley Journalism Collaborative, connecting communities with the resources, infrastructure, and networks to ensure a vibrant local free press.
From KVPR in Fresno, this is Central Valley Daily. Happy Friday, it's January 2nd. I'm Elizabeth Arkalian. Two large glaciers in the Sierra Nevada were thought to be hundreds of years old. New research reveals they're much older than that, and their future is uncertain.
It means when they go away this century, which they're projected to, it means that people will see ice-free slopes for the first time ever.
Coming up, we continue to revisit some of our favorite interviews from 2025. Today, we'll learn more about why glaciers near Yosemite National Park are melting. We'll have that conversation in just a moment.
Support for Central Valley Daily comes from the Osher Lifelong Learning Institute at Fresno State, providing short courses and activities for everyone 50 and better. Spring semester registration begins January 14th. More info available at fresnostate.edu/OLLI, the Osher Lifelong Learning Institute, where learning never ends.
And now to our feature story. The climate is changing, and one feature in the Sierra Nevada is a key indicator of that change. Glaciers have existed for thousands of years in nearby Yosemite and Kings Canyon national parks. But recent research shows these glaciers are projected to disappear by the end of the century. The study was published in the journal Science Advances. To understand how researchers reached this conclusion, I spoke with Andy Jones in October. Andy's a doctoral student at the University of Wisconsin-Madison and a co-author of the paper. He begins our conversation by explaining where the glaciers he studied are and just how big they are in size.
So the glaciers that we studied are in Yosemite National Park. It was the Lyle and McClure glaciers, as well as the Kness Glacier, which is just on like the northern ridge. If you've ever hiked along the Pacific Crest Trail or the John Muir Trail, as you get near Donahue Pass and you look up, you'll see actually the Lyle Glacier right there on the mountain. And you can see it from the Tuolumne Meadows as well. Yeah, and we hiked these glaciers. I would say they're probably a few football fields in size. There's historical photography that's in the paper showing in the late 1800s sort of how large they were. And they used to be 60, 70, 80 feet deep, like thick. And now, at least one of the glaciers, the East Lyle Glacier, is almost entirely gone.
You know, I have to say, when I hear the word glacier, I do think of Antarctica or like a glacier out in the ocean. Can you explain to us what exactly are these glaciers that are in the Sierra Nevada and just how they're different from maybe what comes to mind for folks when they hear that word?
Yeah, so Antarctica is a massive ice sheet. You can think of like pancake batter on a pan, right? It's big and it's flat and it's diffuse and it's spreading out. Antarctica is larger than the size of the contiguous United States. These alpine glaciers, they're more like, blobs of snow and ice on the slopes of mountains. Every year we get snow, right? And it comes top of the mountains. And then eventually, if you have more snow in a given year than you melt away, right? Your snow persists. And you do this over hundreds, thousands of years, you get ice that builds up. And that is the glacier itself. And it's sort of slowly sliding and flowing downhill.
Okay, alpine glaciers. Good to make the difference there. So you made some significant discoveries in a newly published research paper, and one of those is that these glaciers in the Sierra Nevada are older than originally thought. Why is that significant?
Yeah, so people had thought that glaciers in California, Sierra Nevada were ephemeral features, coming and going within the last 10,000 years, which comprises sort of the modern climate state in which agriculture developed, and most of recorded human history is in this time. And we found that glaciers had survived that entire interval, it turns out, which is wild because it means when they go away this century, which they're projected to, it means that people will see ice-free slopes for the first time ever.
Wow.
I mean, if you think that the peopling of the Americas happened, 20,000 years ago, or we had an ice age around that time. So there's been ice there for a really long time, sort of until now.
And how did you measure the age of these glaciers? Like, what does on the ground that sort of research look like?
Yeah, so we quite literally hiked the glaciers, which again, really lovely. Got to do some of the John Muir Trail. Wonderful. You walk right up to the terminus or the edge of the ice. You can literally put a hand on the melting glacier ice and then you're standing on bedrock, right, of which the glacier is resting on. And we do this technique that I'll sort of liken to charging up a battery with a solar panel. When bedrock is not covered by the glacier, it's sitting at the surface of the earth. There's particles from space raining down, and the rock actually becomes charged, so to speak.
Oh.
When the glacier is bigger and it's covering this bedrock, it's shielding it from exposure and it doesn't get charged. And what we found in the rock was no charge at all, which told us, wow, this bedrock has not seen the light of day for a very long time.
Wow. So longer than originally thought. How old was it originally thought to be, and what did you discover that it is?
We thought that you might expect to see like 7,000 years of exposure, followed by 3,000 years of burial.
Mm-hmm.
So 3,000 years ago is when these glaciers are thought to have reformed. And yeah, we were really surprised to see nothing at all.
Yeah. What was that like for you? Was that your first time going to those glaciers?
So the way it came about actually is that we did a study looking at 4 different glaciers in North America, one in Alaska, British Columbia, Wyoming, and the Wind River Range, and then one in California, this Kness Glacier that's on the northern border of Yosemite National Park. And when we got that data back, we saw this sort of blanked signal, and we were like, wow, that's not what we expected at all. Like, we need to go back. So then I actually didn't collect that first round of samples, but then I went back in 2021 to do sort of this mission to go to Lyle and McClure and test those glaciers. Yeah, and we actually ended up going back a third time to really make sure we were seeing what we thought we were seeing.
I have to ask because I'm curious. You're based in Wisconsin, so why study these glaciers in the Sierra? How is this relevant to the work you're doing?
Yeah, so one of the most interesting fun facts is that John Muir studied geology here at the University of Wisconsin-Madison. And he went to California and was actually the first person to document flowing ice on the McClure Glacier in the late 1800s. So there's actually a long tradition of geologists from the University of Wisconsin studying glaciers in Yosemite.
Okay, I have to pivot to some sort of unfortunate findings, though, which is that your research suggests that these glaciers in the Sierra could disappear in the next 75 years. So what is causing them to melt?
Yeah, as the planet warms up, you melt more ice than you make. I think of it as a budget, right? If you run a deficit every year, sooner or later you run out of money. That's what's happening to our glaciers, right? They still get snow every year, but it's less and less snow, more and more melt. And as the planet warms from human-caused greenhouse gas emissions, the glaciers are going to go away.
So what kind of impacts, you mentioned looking back, but also looking forward, what kind of impacts could the loss of these glaciers potentially have on areas like the Central Valley or other parts of California?
Yeah, so the glaciers in the Sierra Nevada have a key sort of ecological role. Most of the water comes from snowpack, right? That's what feeds the rivers. And when the snow melts, and let's say you have a drought year where you don't get a lot of snow, or a really warm year, right? And you burn through that snow. What keeps the rivers flowing at some sort of stable level is glacial melt. When you lose the glaciers, you're sort of losing your piggy bank of water, right, to have for bad times. And it's honestly not clear what the ecological implications of that will be, because in the last 30,000 years, we haven't seen it.
So wild to think about. Before I let you go, Andrew, what's next for you? Will you be coming back to the Sierras to do more research, or what's next after these big findings?
I don't have any plans to come back to the Sierras right now. I'm actually writing a federal grant to come back to the Sierras, which, as you might think, is a little bit up in the air right now. It's unclear if the program will be funded.
That was my conversation with Andy Jones. He's a PhD candidate in the Department of Geosciences at the University of Wisconsin-Madison. I originally spoke with Andy in October. And that is today's show. Today is our last Encore episode for the holiday season, and we will be back to our regular release of new episodes starting on Monday. Today's episode was produced by Jonathan Linden and KVPR with support from the Central Valley Journalism Collaborative. I'm Elizabeth Arkalian. You can find the latest local news anytime at kvpr.org.
How does AI even work? Where does creativity come from? What's the secret to living longer? TED Radio Hour explores the biggest questions with some of the world's greatest thinkers. They will surprise, challenge, and even change you. Listen to NPR's TED Radio Hour wherever you get your podcasts.